Hello, welcome back to Digital Urim. In the previous video, you learned that users do not all have the same level of power inside an operating system. We saw the difference between a standard user, a user with administrative privileges, and, in Linux, the root user. But now we are going to explore something even more important. Because in security, it is not enough to know who the user is. You also need to know what that user is allowed to do. Can the user read a file? Can the user modify it? Can the user execute it? Can the user enter a directory? Can the user change a script? Can the user delete information? These questions may sound simple, but they define the security of an entire operating system. Today, you will learn how basic Linux permissions work, what RWX means, how to interpret permissions like 777, 755, or 644, and why understanding permissions is essential before studying privilege escalation. And this is very important. We are not going to study permissions as isolated theory. We are going to study them as a cybersecurity analyst would. Because many real attacks do not begin with an advanced exploit. Sometimes they begin with something much simpler, a file that should not be writable, a script that should not be executable, a directory that should not be open, or a permission that was made too broad for convenience. In Linux, basic permissions are represented using three letters, R, W, and X. The letter R means read. When a user has read permission on a file, that user can view its content. For example, the user may be able to open a text file, read a configuration file, or inspect stored information. The letter W means write. When a user has write permission, that user can modify the file. They can change its content, add information, or overwrite data. And the letter X means execute. When a user has execute permission on a file, that user can run it as a program or as a script. This is fundamental in cybersecurity because an executable file contains instructions, and those instructions can be legitimate or malicious. But there is an important detail. For files, X means execute. However, for directories, X has a different meaning. In directories, the execute permission means that you can enter or traverse that directory. For example, it allows you to use CD to move into a folder or access files inside a path as long as the other permissions also allow it. This may seem like a small detail, but it matters, because in Linux, file permissions and directory permissions are related, but they are not interpreted exactly the same way. Now let's see how these permissions appear in the terminal. In Kali Linux, if we open a terminal and run ls-l, the system will display a list of files with their permissions. You may see something like this: -rwx r-x r-. At first, this string may look confusing. But it has a very logical structure, and here we must be precise. The first character is not a permission. The first character indicates the file type. If we see a dash, like this, dash, it means this is a regular file. If we see a D, it means it is a directory. If we see an L, it means it is a symbolic link. After that first character, the permissions begin. In the example, -rwx r-x r-, the first character is dash. That tells us we are looking at a regular file. Then come the next three characters, rwx. These represent the permissions of the owner. After that, we have r-x. These represent the permissions of the group. And finally, we have r-. These represent the permissions of others. So the correct way to read it is this: regular file, the owner can read, write, and execute. The group can read and execute but cannot write, and other users can only read. Now we need to clarify something very important. In Linux, we usually talk about three categories: owner, group, and others. The owner is usually the user who created the file or the user assigned as the file owner. The group represents a group of users that may share permissions over that file. And others means any user who is not the owner and does not belong to the group assigned to that file. This is important because if a user belongs to the group permissions apply to that user, not the permissions for others. That detail prevents a lot of confusion. So when you analyze permissions, it is not enough to look at the letters. You also need to look at who owns the file, what group is assigned, and which users belong to that group. Now let's connect this to numbers. In Linux, permissions can also be represented with numbers. This system is known as octal notation, and it is very common in commands, technical documentation, and certification material. Each permission has a value. R, read, is worth 4. W, write, is worth 2. X, execute, is worth 1. When we add these values together, we get a number. For example, rwx means 4 plus 2 plus 1. That equals 7. So rwx is represented as 7. Now let's look at another example. rw- means read and write, but no execute. So we add 4 plus 2, that equals 6. So rw- is represented as 6. Another example, r-, means read only. That is worth 4. Now, when you see a permission like 755, it is not a random number. Each digit represents a category. The first number represents the owner. The second number represents the group. The third number represents others. So, 755 means the owner has 7, which means rwx. The group has 5, which means r-x. Others have 5, which also means r-x. So 755 can be written as rwx, r-x, r-x. Now let's look at 644. The owner has 6, rw-. The group has 4, r-, and others have 4, r-. That means the owner can read and write, but the group and others can only read. And now we arrive at one of the most famous and dangerous permission settings when used incorrectly, 777. 777 means the owner has rwx, the group has rwx, and others has rwx. In other words, everyone can read, everyone can write, everyone can execute. This may seem convenient when something is not working, but from a security perspective, it is dangerous. And this is a good point to stop for a moment. Up to this point, you have learned the foundation of Linux permissions. You learned what rwx means, you learned that R means read, that W means write, and that X can mean execute for files or access and traversal for directories. You also learned how to read the output of ls-l. You learned that the first character indicates the file type, and that after that we see the permissions for the owner, the group, and others. You also learned how octal notation works. Now you know why rwx equals 7, and why permissions like 755, 644, and 777 are not random numbers. Each number represents a security decision. In the next video, we will continue with the most important part, how misconfigured permissions can become a real attack path and allow privilege escalation. We will see why change mod 777 can be dangerous. We will analyze a realistic scenario involving an automatic backup script. And we will connect all of this with the mindset of a cybersecurity analyst. See you in part 2. Understand, defend, grow.